This conference will now be recorded.
So today we are going to enter in system Verilog. Okay, is my screen visible to everyone?
Yes, sir.
Okay. So today we are going to enter in system Verilog. Now, what is system Verilog? System Verilog is used for functional verification. Okay. Now the question comes that we have completed Verilog, right? In Verilog also we have a functional verification. Right. So the question comes, why, if my work is being done using Verilog, so why there is a need of system Verilog? Okay. Now see, everything, every language, that language should evolve, right? If you take the software languages, in software languages, what happened? First, C came, C programming came. After that, C++ has come. Then Java, then .NET, something. So they got evolved, right? So this system Verilog is the evolved or developed, more developed language with respect to Verilog. Okay. Now, why this is needed? Why this evaluation is needed? Because Verilog language has some restrictions as well as limitations. Okay. Limitations means, if I take one example, one limitation is, what are the data types that we have used in Verilog? Can you please tell me? What are the data types we have used in Verilog? Range, and
Range.
where, integer, then real. Array is not a data type. Okay. Now, all this, all these data types are static in nature. Static in nature means, we can't, static in nature means the value got assigned at compile time and can't be changed during runtime. What we mean by compile time and runtime? See, if I write initial beginning, I'll declare what? Before that, I'll declare reg integer a. Okay. And here I can assign the value like 10, or I can assign the value here a equal to 10, right? Now this value got assigned before compilation, right? Before running the code. Am I correct? This value got assigned before running the code. Now when I am going to run the code, this value is fixed for every simulation until and unless I change the value. Okay, but in system Verilog we have dynamic data types. Dynamic data types where we can change the value during runtime also. Okay, how we will see when we are going to learn data types, we will see. Okay, also the also the range of data types are more in system Verilog. So you understand one thing. You understand one thing. This is very important that system Verilog builds on Verilog language. What does this mean? Whatever there in Verilog is present in system Verilog. Many more constructs are being added in system Verilog. Okay, many more constructs are added in system Verilog. See, you understand in Verilog what are the constructs we have. If I go to the PPT, what are the constructs we have in Verilog? Can you remember? Task function we have. We have this task function also in system Verilog. Then arrays we have in Verilog. In system Verilog, arrays are static in nature. In SB, we have dynamic array, associative array. We have okay. When we will enter in array, okay, array is very important with respect to system Verilog. Okay, vectors we have same Then we have fork join. Different kinds of fork join introduced in SB. We have only one type of fork join, right? In Verilog. What we have done, what do you mean by fork join, or what fork join will do in Verilog?
All the statement will execute at same time.
In fork join, whatever the statements are, they will execute concurrently. Okay. If processes are there, all those processes will execute concurrently. Okay. Next, what are there? Clock generation is clock generation. We have same in SV also. Next, anything else? Please tell me. What are the new thing we have? What are the new things? New things we will see in SV. One is the main. The main thing is object oriented programming. Object oriented programming. Okay. See, if anyone can remember Java, that person is a little bit familiar with object oriented programming. Okay. Now, how the curriculum will go on, we will start with same like Verilog. Same like Verilog, we'll start with literals. Literals are almost similar with Verilog. Okay. Next, we'll go to data types. See, now you have to understand one thing. Whatever we have covered in Verilog, we are not going to spend much time on those. Okay. We are not going to discuss here what do you mean by range. What does it mean? What are the characteristics of range or integer? Where we are going to spend more time? The newly introduced data types. There we are going to spend much time. Okay, so object oriented programming, that is one new thing which now why it is needed, why this object oriented programming is being introduced. It will make the test bench development easier for complex designs. Next, as object oriented programming, introduction of class. Next, new data types like int, logic, bit, byte, then short int, long int, etc. Next, new kind of arrays. Dynamic array and multi-dimensional array. Then associative array. Then we will start with Q. We start with Q. We will see how FIFO development got easier using Q. Now you can ask me one question that sir, uh, everything is there in system Verilog, whatever we have learned in Verilog. Okay. Now why we are going to learn Verilog? Why we don't jump directly to system Verilog? That will save almost 1.5 months or 2 months, right? But now the thing is that if we jump directly to system Verilog, in system Verilog, what will happen? Whenever you are going to learn a dynamic array, before that you should have the concept of array, right? You should have the concept of array. Whenever we are going to understand these new data types, before that we should have the understanding of the basic data types. Those are reg, var, integer, real, right? That's why we should understand Verilog is the foundation of understanding the language. Okay, now we will come to constraints. This is the new thing that you are going to learn. Okay, then various use of XMR. Various uses of XMR. Here in system Verilog, what I am telling you, here in system Verilog, how we use class. Okay, whenever we write end class. Now what is the difference between module and end module? This module and end module and this class and end class, what is the difference between them? Can anyone tell?
One module have different classes, sir.
Hmm?
One module may have different classes, but module will be one.
Not like that. See, inside class we can't use any port or signals. Inside class we can't use any port or signals. Port or signals, what do you mean by that? See, while doing the design, what you have done, module, then module name, then you have done port list, correct? You have written port list. In class we can't do that. What we do, we give a class name. Suppose the class name is APV transaction class. Okay, what we do, we will create an object APV transaction plus transaction. So here what we are doing, inside the module, writing the class name, then the object name, we are creating an entire instantiation of the class inside the module. And we can do anything inside the module, whatever constraint we have used inside the class. So class have only properties, methods, and constraints. Properties means inside test bench, what are the properties we have written? Suppose you have a half adder test bench. Test bench you have. This test bench does not have any port, right? Am I correct? This is the very basic thing that we have learned in Verilog. Test bench do not have any port, right? So how we connect the test bench with the design? How we connect the test bench with the design?
TI పోయిందా ఇన్స్టంటియేషన్ సార్
Instantiation.
I am getting answers like reg using macros, reg and where, tick include. All these answers are wrong. Using instantiation of the design module, we connect the test bench with the design, right? Right? This is same method that we do when we want to connect our module with class. Okay, now you need not to go to deep, sir. What is this that we learn in object oriented programming? I am just showing you one example. Now what are the properties of the test bench? Now if I come to the properties of the test bench, those are reg a comma b, where sum comma carry. Those are the properties. What are the methods? That will be task, or function. Whatever task or function we are going to use inside class, that is being called as method. Okay, so class will consist of only these three things: properties, methods, constants. Using this, we are creating an object, of that particular class. And whatever method we are writing here, we are going to call the methods inside the module, inside initial block, and accordingly we'll check the output. This is what we are going to do right now. Next onward, what we are going to do when we complete our object oriented programming. Now, object oriented, now how the curriculum will go on? Curriculum will go on like this. Data types, then array, and string, then array, then queue, then operator. This before the literals. This thing is the basics of SB. Okay. This will take almost 5 to 6 sessions. Take 1 week. Next, hooks concept. Hooks concept means object oriented program concept will take almost 2 weeks to complete. After that, we will implement memory test bench. And before, you have to do by yourself. Then proceed to the further topics. Okay. Now these things here, I will tell the entire thing. 40% is from Verilog, 60% is from SV. Okay. So that 40% we are not going to spend so much time. I will go just by describing, okay, these are the things that were there in Verilog. This is the same thing is present in system Verilog also. Okay. Now in operator, suppose in operator, whatever operator we have used in Verilog, all the operators are present in system Verilog. Some new operators are being introduced. So whatever the new operators we are going to discuss with example. Now if you ask me, sir, please explain bitwise operator again, that is not possible. Or please explain on that. When I am going to discuss the operator topic, if anyone asks, sir, please explain relational operator, it is not possible, because we have spent enough time when we were discussing this thing in Verilog. Array, we are not going to discuss what is array, how to declare array, and how to do the operation using array. We will directly jump to the newly introduced arrays and we will do some example on those arrays. Okay, this is the new thing that we have discussed. String was not in Verilog. Okay, string we use in system Verilog. String. Okay, and also we learn some methods to be used okay. So up to this is the curriculum. These further topics you will get to know after completion of this OOPS concept. Now in system Verilog we have assignments. How many assignments we have? Go to assignment. These are the assignments we have. Almost 15. 15 means if you left out this assignment 1, 14 assignments are there. Each assignment have dedicated question that you have already seen in Verilog. Every assignment should be completed by each and every student. Okay. If not completed and submitted time by time, that person we will not get him or her to UVM. Will make that person to repeat system Verilog again. In system Verilog, please note down this one. Okay. If you want to, what I can say, like you have to remember this one that assignment completion is the most important aspect to learn SV properly. Okay. Now see, we have completed Verilog. Okay. It will take 2 months. 2 months to complete system Verilog entirely. Okay. Now, more or less 2 months. Okay. Now, coming to this assignment submission, we will complete the theory, then the assignment should be completed and checked related with the topic. Then only we will move to the next topic. Now, this means what? This means what? Suppose I have completed data types, literals and data types. In the next theory session, then everyone should complete the assignment related with the data types and literals. Then only we'll move to the next topic. Suppose that is array or string. Now you understand, if you do not complete that one, then you will be the responsible person for getting delayed, of the course. Why I'm telling this? If I complete the topic today only, tomorrow lab session will be there. You start completing the question. Lab mentor will check for each and everyone that what is the progress. I will get the feedback from that person, from lab mentor. Then only we'll plan to go for the topics. Okay. So here what I'm telling, whatever you have done in Verilog, if you have done the Verilog assignments very seriously, then automatically you will do system Verilog also seriously. But if you haven't done Verilog assignments seriously, please do not take system Verilog as taken for granted, the assignments taken for granted, like okay, I will join the theory session, I'll attend the theory session, then I'll not attend the lab session, I'll not complete the assignment. That will be a loss of yours only, because anyhow after some time we are going to check the assignment status. If the assignment is not been uploaded or completed, then the proper reason should be there behind that. And if we see that is happening deliberately, then we'll make that person to repeat the system Verilog again. Okay, repeating is there is no problem, but repeating is waste of time according to your perspective going forward to get a job. Because see, the thing is that what I am telling you, if system Verilog if SV is covered properly by anyone, UVM will not take more than 3 weeks to complete. And the advantage is that if a person is very good with SV, the chances of getting the job is very high for that person. At that time, means what I am telling you, completion of SV, after completion of SV, you can simultaneously learn UVM and can apply for the job. Because see, UVM is based on SV only, but SV is the, if I take the weightage, SV is 100%, is carrying 100% weightage of the entire functional verification concept. I'm telling. Now you can ask, sir, why we need to learn UVM? Because UVM is the methodology that is being used currently for verification purpose. But if you don't understand SV, I am telling you, you will not able to understand a single word of UVM. if a person don't know Verilog, there are chances that they can cope up with SV. But if a person do not know SV system Verilog, that person will not understand a single word of UVM. What is happening in the UVM, that person will not understand a single word. Please mark my word. Okay. Because if anyone don't do it seriously after 2 months, that person can remember my word. Okay. So what my request to everyone is, whenever a topic is being discussed, after that, please invest at least 3 to 4 hours for practicing. For practicing, how you are going to practice? How you are going to practice? Anyone? Is there any easier way to do the practice? Assignment questions. See, if I open this groups concept assignment question, are you able to see how many questions are there? 31 question. 31 is the topic. 31 topics. 31 topics in this particular OOPS concept. Each topic has some 7 to 8 question. Okay. So that's why I told you this OOPS concept will take almost 2 weeks. Okay. That you please
Which
talk with the, please tell me.
which tool we will use for the implementation, sir? Model sim only?
Which we are going to
Tools,
use
sir.
initially EDA playground, then we are going to use QuestaSim when we enter in OOPS concept. Initially you will have EDA playground credential, there you have to practice. Okay. Model sim will not
Okay.
work here.
Okay, sir.
And regarding the class timing, please talk with our admin sir, Manohar sir, regarding that one. Okay. Next. So these are the things you need to follow. Okay. For SB, because see, starting of Verilog, I didn't tell like this. Okay. But why I'm telling you? Because after some time, if you are lagging for SV, it is not possible to pop up. Okay. Because only for OOPS concept you have seen there are 31 to 32 concept to be learned. Okay. Why SV is important more than Verilog? Many concepts are there in SV. This SV is built upon concepts only. If you grab the concept, okay, you are good to go. And concepts can't be learned by just mugging up. You have to understand that one. It is not like that I am writing something and you are just mugging up that one or by hurting that one. It is not like that. You have to understand why I am writing. So here, if I am writing anything you are not able to understand, please ask me that why it is been written. Okay. So we'll go to the PPT once. Just see that one. Verilog we have completed. Okay. So there are the different things that we are going to do in it SV. 14 assignments are there. Okay. If you complete all the assignments, you yourself will get to know that you have become an expert in SV. Same happened for Verilog also. If you can remember, whoever completed all the Verilog assignments and projects properly, okay, that person can understand. That person can understand that that person is expert in Verilog. So that person is good to go with SB. Okay. Same for Verilog. Presentation, session notes, lab session will be there, assignments, and the PU and the course documents are there. Okay, and also you will get the access of live videos. What is the expectation from your side? That's what I was explaining right now. Assignment completion as per schedule. Make the session interactive. Now, why? What is functional verification? A little bit idea we have in Verilog. Why functional verification is needed?
To check the
To
behavior of the
test the
device.
functionality.
The functionality of what?
Design.
Correct. So you have to complete your answer. Functional verification means to check the functional behavior of a design. Whether the design is behaving properly or not. Okay. Now RTL is nothing but the design only. Process of validating design functionality against the design specification. This is also a what I can tell definition of functional verification, that will have a design specification. Okay, we will have a design specification. According to that, the design is been made. Now when I am going to do the functional verification, whatever the functionality I am getting, if it is matching with the design specification, if it is matching with our design specification, then we'll tell that the test is passed. for a functional verification engineer, what is our main agenda or what is our main work? What is our main work? Catching the functional issues or functional bugs, design bugs. This is our main work, to find the bugs. We are not going to fix the bug. Okay, we are going to find the bug, and we will tell the design team that this is the bug we are having. Okay, according to that, the design team will fix the bug. Okay, we have two inputs. One is design specification, one is RTL code, developed by design engineer and integration engineer. Verification engineer develops test bench to make the functional verification more process oriented. Now, here what we are doing, here we are making our own RTL. Like in memory, what we have done, we have made our own design or own RTL, and we are developing the test bench and we are running that one. If any error is there, we are fixing that one. That design is being made by us. But in practical, what will happen? The verification engineer will receive the design specification and the design file. RTL code means the design code. They will receive that one. So your first work will be spent, means see, when you receive a design specification, your main work will be to understand the specification and get the deep knowledge. Because if you don't understand the design specification, you will not have the idea to develop the test bench. Okay. Now how you can become a very good verification engineer? First, by experience. Now how the person gain experience? Suppose a person is in industry for almost 10 to 12 years. Okay, for almost 10 to 12 years. Now that person is has been worked for almost 20 to 25 projects. Now when we tell 20 to 25 projects, 20 to 25 projects means 20 to 25 design specification that person has read, understand, developed the test bench and executed that one successfully. Okay, so when a person is able to understand 20 to 25 design, okay, so that person has become very much diversified. Okay, so what will happen? Whenever that person will receive a particular design specification, on that point of time, that person will understand the approach to develop the test bench. But suppose one person is working on the project for the first time, that is his first project, so that person will receive a design specification. So he or she should invest more time to that particular design specification to understand that what is the functionality of the design of that particular design. Okay, now it is not like that you are going to do that alone. Entire team will do that one by one. There will be meetings That is internal thing for a company. That varies for company to company. Then after understanding the design specification, you'll see the design, and accordingly the test bench will be developed. And whenever some bugs is been detected, that we need to understand that why the bugs is coming, why the bug is coming. We need to give that idea to the design team that this is the reason the bug is coming. Please fix that portion, or please fix that one. Please fix that one. Or this is the reason the bug is coming. So you please go there and check whether that is correct or not. So for a design engineer, they will design. But for verification engineer, we need to understand the design also and also develop the test bench. That's why in Verilog, what we have done? In Verilog, we have done the design also. Now my question is, design is been done using Verilog or system Verilog? Verilog. A design is been done using Verilog or system Verilog? A design or RTL code is always been done using Verilog. What is the reason behind that? A design is always implemented using Verilog synthesizable constructors. Design is always implemented using Verilog synthesizable constructors. Why? Because after verification, it will go to the fabrication stage, where the where is been converted to logic gates and been fabricated. That's why synthesizable. Synthesizable means that can be converted to a logic gate which can be fabricated. Fabricated means the physical or the actual part of the design, which we can see. This code are the functionality that we are writing. These codes will be converted to RTL. RTL means that will be converted to logic gates. Those logic gates will be fabricated according to the functionality. We check the functionality. If the functionality got passed, only then the RTL will go to the fabrication stage. Otherwise, it will not go to the fabrication stage. Because see, if the entire functionality is not passed, then what will happen? The design has some bug. Now industry do not implement anything that has a single bug or that has a single issue, because that particular issue will hamper the entire functionality of the design. Okay. Now, why not SV? Why not SV? SV has more non-synthesizable constructs. That is why it is been used to develop the test bench is not synthesizable, because whatever the test bench we develop, that test bench will not be converted to any gate level, or it is not been fabricated. Test bench is something that we develop according to our logic to understand. Suppose I can take one example that mm, particular, if you take one thing, that one device that is not working properly. Okay, one device that is not working properly. Now what we do, maybe the television is not working properly. Then what we do, we call a particular person who knows how to fix the television. Okay, now that person implements some logic, correct? There, the logic is present in that person's brain, that okay, I am getting this problem, maybe if I fix this, then it will work. So this idea, maybe if I can fix this, that idea is related with test bench, which is not physically implemented, which cannot be physically implemented. Okay, see, functional verification can happen in two stages, where one at functional verification stage, another is post silicon validation. Post silicon validation is different thing. Now if functional verification is not happen properly, then what will happen? The bugs will be there in the particular design. Now when during synthesis is a part of physical design. Okay, now when it will go to the synthesis stage, it will give you the wrong net list. It will give you the wrong net list. Now what is net list? That is related with physical design. You please understand this one. It is not like that you have to remember that one. You just understand the flow. Then physical design will be done on wrong netlist. If this stage is been done, then definitely we'll get a wrong chip, because after this, there is no stage where we are going to check whether the functionality is correct or not. Okay, now understand in a bigger level. Suppose a company, XYZ company, they are implementing a chip. Okay, and the order is of, suppose, 2 lakhs. 2 lakhs of chip another company has ordered for that, from that company. Now that company who is building the chip, they do not have a very good verification team, functional verification team. Okay, And what happened? The functional verification gone wrong. They didn't check the entire functionality. Okay, they suppress some bugs and they just allow the design to go to the fabrication stage. Now when the fabrication is been done, bugful chips are been made. When the fabrication is been done, 2 lakhs of that, and that company delivers all the chip to the main company. The main company develops some devices with those chip. Suppose mobile they have developed with that particular chip. Okay, now you understand 2 lakh mobiles is been made which is not functioning properly. Now when the fabrication is done, no one can do anything. The entire investment and entire money has been wasted. That is what happened now. See, have you seen some mobile company, they launch some mobile. Okay, after 1 month or 2 months, we get to know that that phone got heated. Suppose you are playing some game, after 5 minutes or 10 minutes the phone got heated very much. So what happened after that? If so many complaints come, then the company will take all the entire stock, will take away the entire stock of that particular mobile from the market. Then what they do, they again do the verification. Okay, then again they need to do the fabrication, and that you have seen that refurbished version is been introduced or is been there in the market, that you have seen. I think that the name of the mobile, this RAM, this ROM, and refurbished or relaunched means bugs were there, they have fixed the bug, and now they again launch that one. But this entire flow will be a loss for that particular company, because if any product, the customer got to know that if any product is not working properly, they will not buy that one. Now for this developing the test bench, if we use SV, it will take less time in developing the test bench, more time on developing the test cases and debugging those. See what we have done till now in Verilog, we develop the test bench, inside that we develop some test cases. Now what we do, we are going to suppose one test bench we develop. Okay, we will reuse that test bench for another design, only will change the test cases, and again we run that one. Okay, but this is the same thing we have already discussed, that you can go through these slides. Now coming to the test bench architecture, this is the test bench architecture in system Verilog. You please see this one, then I'll explain that. Yes, we do that. We build the test bench from scratch, but in company what will happen, uh, here we are going to build the test benches from scratch only, but when we get to know the functionality of the design and we can remember that we can reuse that test bench what we have developed previously, we are going to use that one. Okay, now see here, what is this one? This one is DUT. It has been written DUT. What is this? I am not asking the full form of DUT. What is this? Can anyone tell? This is the design that we are going to verify. Okay, this is the design. Correct. This is the design for which functionality to be checked. Not instantiation, this is the design only. DUT that we have used in Verilog test bench, that we have used for the module instantiation name only. But actually DUT is the design to be tested. This is the design file that the functional verification team is going to get. Okay. So now what, see, by seeing this now you are thinking what are these, what are these? Now I am going to explain. See, I am going to explain this test bench architecture for now. When we are going to implement, the memory test bench, we will explain this again with the example that how we are going to do. But for now I am going to explain that how it will work. Okay. Now what I told you, that we will have a design file. So what I am going to do, I'll take a this is my this is my design file. Okay, design. Okay. Next, this reference model or register model, reference model, this is what, this is the replica of the design that is been made by the verification team. Reference model or register model, which is a replica. See, we get the design file. Okay, we have received the design file, we understand the specification, and by understanding the specification the verification team has built one one reference model, where the output of the reference model and the design output, we are going to check whether both are same or not. What is that? Another is the reference model. Reference model. Now Reference model is what? Now, testament architecture. What are the components? I'll write one by one. One is generator. Number two is BFM. Number three is monitor. Number four is functional coverage. Five is reference model. Six is seven is scoreboard. Another one is slave model. Is okay. And we have design. Now, this design, why I am keeping them separate? This design built by design team. Now, another thing, you please understand. This design file, this design file, we can't edit. We can't edit this design file. This is the reference thing we have. We will see the uh, specification of the design. We understand the specification of the design. We build this reference model. What is this reference model? Please be muted. Please be muted. Design.
reference model UT design.
This design file input from design team. Okay. Also design specification. Okay. Next. The next work. The next work by the functional verification team. Understand no reference. Sorry. Understand the design specification and implement reference model by verification team. Okay. Means this reference model output. Okay. Now this reference model output and this design model output. Okay. if both are same, if both are matching, okay, for every aspect, for every test cases, if both this and this are matching, then we'll tell that all the test cases are passing and the test is passing, so this design is bugless. Means see, this reference model, the testing team, they are building with the help of the design specification, and they are checking if this output and this output is same, then only will tell the test is passing. Now this design, it is been written using Verilog or system Verilog. This design file,
Verilog.
Very low.
hmm? using
Very low.
Verilog, using Verilog. This reference model, it has been written using Verilog or system Verilog. This has been written using SV. Now, why SV? Why SV? Because this is just a reference. This is not going to be synthesized. This is not going to be be synthesized and converted to any logic gates. It is not going to be fabricated. This is going to be fabricated. We need to check for this one. Means if you take one example, I am building something. I'm building something, or I'm painting. The best example is I am painting. Okay, so what I am painting, I need something, right? That I am going to see and I am going to paint. I am painting one tree, right? So I need to see the tree, correct? I need to see the tree, understand, and then I'm going to paint. Okay, so that tree, what I am seeing, that is my reference. What I am painting, that is my design. That is going to be the output. That is going to be fabricated. Now, if I take this one, okay, so this left hand side will have some blocks, right hand side will have some blocks. Okay, left hand side blocks, what are the blocks will be there in the left hand side? In left hand side, whatever the blocks are there, they are responsible to drive the test, to generate the test cases and drive the test cases. Where? To the design. In left hand side blocks, they are responsible to generate the test cases and drive the test cases to the design. And what are those blocks? Those blocks are one is generator. See, by generator, what do you understand? By generator name, what do you understand? It generates, correct? It generates. And this is what? BFM. BFM full form is bus functional model. BFM full form is bus functional model. So generator will generate the test case. So generate the test case. That is test case. BFM will drive the test case to the design. BFM will drive the test case to the design. Do you understand this one? Now, generator is been written in SV. BFM also written in SV. SV, wherever I am writing SV, SV means it is been written using OOPS concept. Using object oriented concept means all these thing have class. Okay, class to class communication will happen. Class to class communication will happen with help of mailbox. Class to class communication will happen with the help of mailbox. So mailbox is nothing but a buffer. Buffer means we will put the transaction inside mailbox. This will get the transaction from the mailbox. Simple. Put and get method that will explain going forward. Okay. For now, you please understand. Now see why I am explaining this, because this will be explained again. But on that time, we are not going to spend so much time in this. So please understand, and whatever you can remember, please remember. So that will be helpful for your future understanding when we start with memory test bench development. Okay. Next, BFM and design. Now you understand this one. BFM is written using SB language. Design is been written using Verilog. SB has class. Verilog has module, which consists ports, right? Which consists ports. So this has port. This has class. Class to port communication will happen using interface. This to this communication will happen using interface that we'll understand later. Now whenever this communication is happening, we need one monitor in between. We need one monitor. Monitor, what monitor is going to do? What monitor is going to do? What monitor is going to do? BFM is bus functional model which drives the test case from generator to the design. BFM drives the test cases from generator to design. Also called as driver. Some company use BFM, some company use driver. Generator is what? Generates test case scenarios. Now you understand one thing. I told you in the PPT you have seen one line that now we will spend less time to develop the test bench, more time to generate different test case scenario and drive that to the design and check whether the design functionality is working fine or not. That's why it generates the test case scenarios. Now what monitor will do? What monitor will do? Suppose uh, suppose there are 10 functionality. There are 10 kind of functionality that will cover the entire verification of a particular design. 10 means just a example. There are 10 type of functionality. Okay, the generator generates seven out of them. Seven out of them test case functionality. It enters the design, check, and we get the result. What monitor is going to do? Monitor will monitor, this block will monitor how many test cases are passing. How many test cases are passing, and it will tell the functional coverage. This is functional coverage. This block is functional coverage. Monitor will tell that this many test cases are being passed. This many test cases are being passed. This functional coverage knows how many test cases need to be passed to get 100% coverage. This will calculate and tell functional coverage is this percentage. Until and unless functional coverage we get 100%, we will tell the testing is not completed. So this will tell, suppose I need to pass 10 test cases. Okay, I have passed 7 test cases. So what is my current functional coverage percentage?
Three.
Hmm? What is my current functional coverage percentage? I know I need to pass 10 test cases. 10 test cases, if 10 test cases passed, then the coverage will be 100%. But till now I have passed 7 test cases. So this functional coverage will tell
70.
how much coverage has been done. 70%. Now if I get 70% functional coverage, at that point I get to know that 7 test cases has been passed but 3 test cases did not pass. Then I'll check for those 3 test cases. I'm not going to check the entire functionality. I'm going to check for those test cases which are not getting passed. So this functional coverage will tell me that one. Now you understand that how we are making our test bench dynamic. This is the input part. This is the generation and driving part of the test bench. This is also SB language. SB language. This is also SB language.
Excuse me, sir.
Again here, yes, tell me.
So why we need a BFM between generator and design? Why can't we directly send it to the design? Why we need a driver between them?
Generator only generate the test case. So there should be one driver who is going to drive the data, drive the test case to the design. Generator can't drive. Generator can generate the test case. Means in Verilog, what you have done? Inside initial block, we were generating the stimulus, correct? Correct or not? Inputs equal to dollar random. Inputs equal to dollar random. We are generating the inputs. What was driving that those inputs to the design? The instantiation, right? So here that's why one driver is needed which will understand which where generator will generate the test case, put that test case to the mailbox. Mailbox is like a buffer, or you can tell it will work like a FIFO. It will drive that test case. It will the BFM will get the test case from this mailbox and will drive that to the design through interface. Now the question why a driver is needed, because the generator is been built like that it will only generate the test case. It is not going to drive the test case. That's why. So this is the input. So here this communication will be done by which one? From monitor to functional coverage. This communication will be done using which one?
Mailbox.
Correct. The mailbox. Because see, whenever you see SV to SV communication, means the communication is happening class to class. Class to class communication will happen using mailbox. Class to module. This is module. This has been written inside module. Inside module. This has been written inside class wherever it is SV. From SV to Verilog, you think like that, SV to Verilog, or from class to module. This communication will be done using interface. This communication will be done using interface. Okay. Now, my this is my test case generation and driving part. Okay. Now this part will be checking part. Now here we will put one checker. By the name of checker, you can understand that what it will do. By the name of checker only, we can tell what it will check. What it will check?
Reference module output.
Match and mismatch.
Whatever, whatever the output we are getting from here and from
Yeah.
here, whether they are matching or not.
Okay.
Whether they are matching or not. This checker will do that. Next block will be scoreboard. By scoreboard, what I can tell?
How many match and mismatch happen?
What is the percentage of match is happening? Or how many matches happen, how many mismatches happen? By that only I will decide whether my tests are passing or failing. If the match is 100%, I will tell all my test cases has been passed. If the functional coverage is 100%, I will tell all the test cases is been driven. All the test cases is been driven. If my scoreboard is 100%, then what I'll tell, all the test cases has been passed. Do you understand this one? Any confusion? This is the basic part. Now you can ask, sir, what are these? These are the block I can understand. You have drawn all these blocks, mailbox, everything. I can see here, I can understand. These are the components of a test bench. SV test bench will consist design, generator, VFM, monitor, reference model, checker, scoreboard, functional coverage. These are the different components that we are going to build. We are going to build to do the testing for this design. Now you can tell that, sir, so many components. Now this is becoming very much complicated than Verilog, because in Verilog what we have done, sir, one design is there, one test bench is there. In the test bench, we are just writing the test bench, different test cases, and it is getting passed. But see, we we can't test every aspect of a design there. Here what we do, here there will be some transaction class will be there. Okay, some common class will be there. There you will see that how we are going to develop the test bench, that we will see when we are going to develop. But for now, what you need to remember, just need to remember that these are the test bench components that is going to be used for doing the testing or doing the verification. Now another component will be there here, that is here and here, that is assertion. Assertion. What is assertion? There will be one top module, their seed concept will come. There will be one top module where we are going to generate the stimulus, their seed concept will come. These are the different components to drive the test cases and understand whether they are getting passed or not. So in this entire thing, there will be no seed concept. Okay. Now assertion, what assertion will do? Assertion means if any temporary error is there, it will detect at that time. If any temporary error is there in my test case passing, assertion will detect that error on that time. Checker also detect the error, but what checker will do, will detect the data integrity error. Data integrity error means, suppose in the design, I am doing 6 plus 7 equal to 13. Correct? 6 plus 7 equal to 13 in this design. Now I know I will get the output as 13. Okay. Suppose I should get 13, 6 plus 7, 6 plus 7. This is my design. Understand, 6 plus 7 is my design. Equal to 13. That should be there. That should be there in the checker. I know I should get the output as 13. So I drive 13 by the reference model. I drive 13 by the reference model. But instead of 13, suppose I am getting 11. I am getting 11. 6 plus 7, whatever the logic I have written, I am getting 11. So checker will be passed. What checker will do? Checker will check this 13 and this 11 are same or not. Means this data and this data are same or not. That is called data integrity. So if these two data is not same, the checker will tell the checker will tell the scoreboard that pass is 0%. It is not passing. From here to here, the test cases will go by mailbox. From here to here, the test case will go and check the design. This is the result what we are getting. This is the result what we are getting after the test case checking of this particular design. If this and this are same, scoreboard will tell the test case is passing. Now I have 4 test cases. Generator has generated 4 test cases, but driven only 2 test cases. Monitor knows that 4 test cases got generated. How monitor knows? That's how the monitor will be developed. Monitor will tell the functional coverage 2 test cases pending. Functional coverage will tell 2 test cases pending. So the generator have to pass the pending 2 test case. By the BFM, it will go here and will get the result. So this is the entire flow of our test bench architecture. Now again I am telling, whatever I have explained, my assumption or my expectation is that if you can remember at least 30% of this one, whenever after completion of OOPS concept, whenever we are going to build the test bench, start building the test bench, understanding that one will be easier for you. Okay, because these are the test bench components that we have. This slave model, why I didn't implement that one? This slave model is okay. Here also one monitor should be there. Here also one monitor is there. This monitor will monitor what? Whenever assertion is been connected, then we need to connect monitor also, because that monitor also monitor if any error is there or not, if any error is happening or not. So here also we need to connect one monitor. How we connect? That connection we will understand when we get to know interface, how to use mailbox. So in between many things you are going to understand, only then we are going to implement this one. Why I have explained that one? So that it will be easier for you to understand when we are going to develop the actual test bench. Okay. So these are the scenario. For scenario generation, these are the three components. For checking behavior, these are the components. Why do we code test bench so many components? That question will come many times. Now you please understand, what do you mean by modularity? Assertion is if any error is happening here in this particular transaction, assertion will detect that error at that time. If any error is happening during this transaction, assertion will detect the error at that time. Assertion and functional coverage is a different topic that will take 2 to 3 sessions. Okay. Now coming here, what do you mean by modularity? I will explain in a short manner. Have you listened regarding the modular kitchen? This flat is having modular kitchen. So what is the difference between normal kitchen and modular kitchen? In a normal kitchen, everything there in a single place. Everything is there in the single place. One oven will be there, one cylinder will be there, all the pots and everything that will be kept in a single place. If you take one room, if you take one room, suppose I have bought one flat. That flat has only one room, one hall, one big hall. In that particular hall, one portion is being used as kitchen. That is open. Okay. So living there is easier, or if you are buying one flat where separate rooms are there, separate kitchens are there, separate washroom is there, and separate hall is there, which one is better? Which one is better for living? Where everything is separated, everything, every room or every portion has some particular specification. This is the kitchen, this is the washroom, this is the room. This is called modularity. This is what called modularity. Each and every block knows what is their work, and those work is been divided in these components. Previously what we have done, we have developed only one test bench only. Inside that everything we were doing. So what was happening, our it was not diversified, it was not diversified. Whatever the test case we know, only that test case we can pass. Now if we have any complex design, if we have any complex design, then what we are going to do? We need this modularity for that one. We need this modularity. So each and every block knows what should be done by them. They will do their work only. Only thing what we need to take care of, we need to take care of the different test cases. Different test cases will be driven and it will do its work, and we need to check the scoreboard and functional coverage. This is the main
Hello, sir.
usefulness of this. Yes, tell me.
So can you repeat what is the use of scoreboard, sir?
Scoreboard will tell you what is the percentage of matching is been done, whatever the data is coming from reference model and whatever the data is coming from this one, the actual design. If these two data is getting matched, the scoreboard will tell the match is 100%. 100% means the test got passed. Now if the
Okay,
scoreboard
test
value is
cases.
70%, 70% means 70% is matching, but there is problem in 30%. So again we need to change the test case and we need to run. Every time this functional coverage and scoreboard data should be full. Full means that should be 100%. Okay.
Okay,
And
sir.
same
And assertion, what is it? Assertion, sir?
assertion will detect. Suppose when I am driving the test case from BFM to this design file, and monitor is monitoring how many test cases is been passed, there is some error happening. There is some error happening because there are high chances error will happen in this and this, here and here, where the test cases is been driven to the design and we are getting the output from the design. There we are using assertion so that if any error is happening, this assertion will detect the error at that particular time.
Okay, sir.
Assertion will be used using assert. Assert keyword, what it will do, if the value got passed, if the value got passed means if it is passing, it will not give you any output. If it is not passing, it will give you a assertion error.
Okay, sir.
And also for reusability. Okay.
Excuse me, sir.
Yes, tell me.
Sir, if in the scoreboard it is showing 70%, means that is 30% test case is not passing through the mailbox. So
Correct.
generator will generate more test case for that.
No, 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 no. This scoreboard is telling my test is passing 70%. 30% it is failing. So we need to change the test cases. We need to generate different test cases for that one.
Okay, sir, understood.
So scoreboard should be 100%, right, sir? Else you need to check the test case once.
Scoreboard should be 100%. If it is 100%, then only we can tell that the functionality of the design is working 100%.
Else you need to check the test case.
Yes.
Okay, sir.
This traffic light control, you need not to worry about that. That we have already discussed. TLC is the duty. From BFM, test cases has been driven. Monitor is checking. Reference model is there. Checker. Modularity, reusability also we have discussed. This is the same one. This also we, what are these? These are the topics mainly we are going to discuss in going forward in this particular course. These are the main topics. Okay. First data types, operators, then arrays. Okay. Then we will see, uh, start with object oriented programming. Then one by one we'll go according to the slides.
Hello,
So
sir.
this is the need for system Verilog. Yes, tell me.
So can you please repeat what is the use of mailbox, sir? Functionality of mailbox?
Mailbox is used as a buffer. Mailbox is used as a buffer, where, see, buffer, what we know, it is like a FIFO. Okay, so the transaction, whatever the test case is being generated, that transaction will come to mailbox. Mailbox will give that transaction to BFM. We can't use ports here or signals here, because this and this are been written inside class. These are not modules, because that's why I mentioned SV. SV means object
Yes, sir.
oriented programming is being used. So there we can't use ports or signals, right? Till now what we have learned, any data transfer or transaction is happened by ports only, correct?
Yes, sir.
But here, as it has been written, both the logic is been written inside class, we can't use ports or signals. That's why we are using mailbox. Mailbox is something that is used as a buffer, where we put the data, and where we need to transfer the data, that will get the data from the mailbox.
Okay, sir. Okay.
Here also we need to use mailbox. Here also mailbox. But here we need to use interface, because connection is being made from class to module. Module has ports, this has class. So class to module communication will be done using interface. Now you can go through this slide. This is pretty much simple slide. Why we, what is the need for a system Verilog? Assertion also SV. In this entire structure, only this design has the port. Only this design has the port. What do you mean by slave model? See, from this design, something is going out, right? We are checking what is the output, but some actual output is going out, correct? So that is been stored inside the slave model, because we can't keep this one open, right? Any design that is a physical design, right, that has some output, that output should be stored somewhere. That is been stored inside the slave model. Complex designs, more number of features. So complex features, complex protocol means, see, whenever we come to complex design means, we have seen in SPI that we can do write transaction, but doing read transaction, it is becoming very complex. But when you learn the SB test bench, the SB test bench structure, Developing that one will be a 10-minute work. Developing that one will be a 10 minutes work. Okay. Also see, in Verilog test bench, in Verilog test bench, do we understand how much test cases is been passed? We can drive only one test case at a time. Okay, now here the way we are developing that one, we can drive how many test case I want, how many test case I want to drive, and accordingly it will give you the result. The result will be reflected inside functional coverage and scoreboard. Okay, so there will be a particular tracking system, how much progress of the project. But if I do it in Verilog, there is nothing, I can't track, because see, our industry is not restricted in memory design or FIFO design or pattern detector. It is very huge industry where many complex projects are there, where you will find the design will consist 1 lakh, 2 lakh lines. So on that design, there are more than 100 and 200 functionality to be checked. For that, many test cases should be passed. Okay, so for that one, system Verilog is needed. Okay, running in QuestaSim, see, for QuestaSim, uh, the steps are same. What we have used in model sim, the steps using QuestaSim is same. But for now, we don't use QuestaSim. We are going to use EDA Playground. Okay. So when you will be added in the System Verilog group. Please ask for the EDA Playground access. For now, it is not needed. When you have been added to the System Verilog group, okay. After that, please ask individually the EDA Playground access. Okay. This one, this one we are going to start from the next session. Okay. I think tomorrow and day after tomorrow there are mock interviews, right? Mock interviews is been scheduled based on Verilog basics and project. Okay. So here I am going to end the session. Please give your attendance. After that, I'll end the session.
Sir, mock interviews, I'm not getting, I did a Verilog course from the other institute. Then, what will be asked here?
No. See, whoever completed Verilog course from this institute only, for them mock interview will be there.
Oh, okay, okay, okay.
Okay.
So
If
I
you
can't
have
give.
joined, if you have joined for the system Verilog only, means new in the
Yeah.
system Verilog, mock interview
Hmm.
is not applicable for you.
Oh, okay, okay.
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 The mock
Who have
interview
completed
is
Verilog from here only, mock interview is applicable for them only.
some mock interview on Verilog basics and projects both, sir, or
Basics and
projects.
projects. Basics and projects, both.
Okay.
Okay. So please be prepared for the mock interview. Uh, give your attendance. After that, I'll end the session.
Sir, we will give our attendance as April Verilog batch, sir, or SB June batch, sir.
SB August. Your batch name will be SB August, not SB
Okay,
June.
sorry, sir.
Okay. If it is not added there, you give your according to your Verilog batch only. Whether Verilog April or Verilog May.
Sir, I have joined the SV August batch, so how we have to do the attendance?
You have joined new
Yeah, SV batch.
for SB batch, na? Uh, okay. You please ask for the attendance link. Okay. You have one individual
Okay.
group, correct? You have one individual group,
Yeah,
right?
SV
So
August,
there,
right?
please ask for the attendance link. Okay.
Okay.
Yeah.
Thank you.
Question can be asked from both design and test bench, or any design can be given and it is been told to develop the test bench. When will be the next session? That you will get to know in the group. When will be the next session? Okay, that notification you will get. Okay, so I'll end the session here. Thank you, everyone. Please prepare for the mock interview.